Let's solve some board questions here. A point charge is placed at the center of a hollow conducting sphere of internal radius r and outer radius 2r. So internal radius of a hollow sphere is r and the outer radius is 2r. And there is a charge kept at the center, and we have to find out the ratio of the surface charge density of the inner surface to that of the outer surface, that is sigma in divided by sigma out. So sigma in, we know the formula, it is a charge per unit area. So charge enclosed by this inner surface is q divided by 4 pi r squared, that's the radius of the um, inner sphere. And then the sigma out is q divided by, because it's also having the same q inside the outer sphere, also it should be the same charge. So same charge, but its radius is 2r, so it is 2r whole square. So let's write this way: q divided by 4 pi r squared times 4 pi into 2r whole squared divided by q. So we have q will go away, 4 pi will go away, r squared will go away. We will have 4 divided by 1. So the answer is 4 is to 1. Let's see the next question. The torque acting on an electric dipole in an electric field is maximum, and for what angle we have to find out. So torque, we know, we can write this as p cross e, and the magnitude of a torque can be written as pe sine theta. So sine theta is maximum when theta equals 90 degree. So the torque will be maximum when the angle between dipole moment vector and the electric field vector is 90 degree. Let's see the next question. If the electric flux entering and leaving a closed surface in air is phi 1 and phi 2 respectively, what is the net electric charge we have to find out? So if there is a closed surface, if the electric field is entering, then the net charge is actually should be negative. And if there is if the electric field is going out of the surface, then the net enclosed the charge will be positive. So now we have to find out the net electric charge enclosed within the surface. We have to find out. So let's first write phi 1. It is actually q1 divided by epsilon naught, and phi 2 equals q1 should be minus because it is entering the field, entering the surface, and phi 2 is plus q2 divided by epsilon naught. So we have to find out the net charge inside the surface. So we have to write here minus q1 maybe we have to write q1 q2 here divided by epsilon naught. That will give you the change in the flux phi 2 minus phi 1. So we have to find out q2 minus q1. So it will be q2 minus q1 is the net charge enclosed by the surface. So we have to write here it is a phi 2 minus phi 1 times epsilon naught. That is the net electric charge. Electric flux through a spherical surface shown in the figure. So we have to calculate the electric flux. What is the formula? Electric flux equals Q enclosed by the surface, by the closed surface, divided by epsilon 0. So Q3 is out, so we should not take into account, and we have to just take minus Q1 and plus Q2. So it will be Q2 minus Q1 divided by epsilon naught. So that's the answer here. The electric flux is Q2 minus Q1 divided by epsilon naught. Thank you.